today's video reference, we're going to learn about graphing linear functions, but using the most famous linear function form, which is the slope. If you want to copy this in intercept form. So slope-intercept form is a famous form, very popular in 8th grade math, which is y equals mx plus b. So really the two variables that you're focusing on when you graph using mx plus b is your m term and your b term. So let's look at b first. So b is your y-intercept. So if you think back when we learned about intercepts, can someone raise your hand and tell me, how do you find the y-intercept? Yeah, you make x equal to 0. So if you kind of look back at your form, right, and if you were to make x equal to 0, which would be right here, what are you really just going to be left with? Yeah, you'd always just be left with y equals b. So your y-intercept would always just be whatever your b term is, or your constant. So that is your y-intercept. And then your slope is your m term. So we'll write here, remember, slope also stands for rate of change. So as long as you know, as long as you have it in this form, mx plus b, all you really need to do to graph is start at your y-intercept and move according to your slope, and you get 2 points that way. So before we practice that, just want to show you on Desmos, if you kind of look here. So in this first one, can someone tell me I graph 2x minus 2? What's the y-intercept? Yeah, -2. Now watch what happens here, as all these are the same slope. See, the slope's always 2, 2, 2, and 2. But now look how I change my y-intercept. So here, now it's positive 2. Here, what's the next y-intercept going to be? Yeah, it's going to be 4 here. And then here, in purple, it will be 6. So it kind of lines up nicely there for the y-intercepts. And if you notice, what's another characteristic of all these lines that you could say is true? Yeah, hopefully you notice that they're parallel to each other. Why? Because the slopes are the same. 2, 2, 2, and 2, and you get parallel lines. And again, as the y-intercepts change, it goes from -2 to 2 to 4 to 6. Also, just wanted to show you slope-intercept form is so popular. I think I showed you this last week. You might want to get a tattoo of it on your finger. I recommend you do not do that. All right, so let's go through here and try some examples. So in the first example, it's 5x minus 3. So imagine how close this, how easy this is going to be compared to doing this with tables. So the first thing you've got to do is, can someone identify the slope here for me? 5. So that's your mx plus b. And then what's the y-intercept? -3. Okay. Now, a lot of times we write slope as a fraction. So how would you write 5 as a fraction? 5/1. All right, so watch how easy it is now to graph. So the first thing you do is put a dot at your y-intercept. So down here, -3. And then how do you think you'd move according to that slope? So we go up 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Usually sometimes you can get 2 points, sometimes you can get 3, sometimes you can get like 6 points, but this one goes off the graph, and I will just make a straight line like that. That's how simple it is to graph in slope-intercept form. The next one here, so we have to do a little bit of work to this one. It's not in slope-intercept form. So what do you think you'd do first to make it look like y equals mx plus b? Yeah, you'd probably subtract x on both sides. So you'd be left with 4y equals -x plus 6. And then what's the next step? Divide everything by 4. Does anyone know how I would write this fraction here? There's an assumed 1, negative 1/4 x, and then plus 6 divided by 4. This is going to get a little ugly here. So that would be 3/2 or 1.5. All right, so now let's identify the slope and the y-intercept. So someone raise your hand and tell me what's the slope. Negative 1/4. And how about the y-intercept? So that would be 1.5. And this is your m, and this is your b. All right, so we're going to graph it. Okay, a little bit different here, but we can do it. So we're going to put a dot at my y-intercept. So I want to take the laser and put a dot at the y-intercept. Yeah, so it's going to be right here, 1.5. Okay, so now we're going to use the slope. So I'll write it over here to the side. It's always kind of good to put it here. So we'll put b equals 1.5. Then m equals negative 1/4. All right, so how do you think you'd move from the y-intercept negative 1/4? Yeah, you'd go down 1, right 4. So we're going to go down 1, right 1, 2, 3, 4. And then how do you think you'd get a point on this side? So remember, it's rise over run. So we're going to do kind of the opposite of down 1, right 4. We're going to go up 1, left 4. 1, 2, 3, 4. Put a dot. And then we can graph it here. So that's just a little introduction to graphing these. Maybe we can do one more on Desmos. That would be pretty simple here. Let's copy this down. Y equals negative 1/2. Sorry. X minus 3. So I'll leave the video here on Desmos, and we can do it up on the board together, and then we'll check it, see how that comes out. So if we go to the graph, we'll zoom right there.